Good morning, everyone. I hope you're having a great day, and I hope that you're getting ready to come back together. And I'm looking forward to having everybody in class. I think it's going to be great. But anyway, today we're going to talk about research methods. Or we're continuing more talking about the research methods, but today we're talking about experiment design, which is essentially how do you create your experiment to learn about what you're trying to figure out. And so when it comes to experiments, an experiment is basically a method where a researcher manipulates one variable and observes the effect of that manipulation on another variable. So basically, you're trying to determine which, what has an effect on what. And this may take many different attempts. And the idea is that you're manipulating factors while you keep other ones under control. So you're trying to determine through experimentation what works and what doesn't. Now, naturalistic observation, case studies, and surveys are all valuable for describing and making predictions about behavior and mental processes, but these methods only offer clues about the reasons behind their results. An experiment focuses on cause and effect. If the only difference between the two groups is the treatment, then any differences between the groups at the end of the experiment should be caused by the treatment, not merely correlated with it. Meaning, by the end of the experiment, you should know what's causing something or have at least a much better idea. But you're not necessarily looking for correlation, which we'll talk about later. Okay? So if we're talking about, examining the effects of breastfeeding upon intelligence, what would be your independent variable? And in this case, it would be the breastfeeding. That's the thing that you can control. Okay? So you can determine how much or how little is being given to the child. Whereas if you were to talk about the dependent variable, this is the factor that changes in response to the independent variable. So if your independent one is the one you're manipulating, dependent is the one that will be affected. So in this case, when examining the effects of breastfeeding upon intelligence, what is the dependent variable? You should think the baby's IQ, because that will be directly affected by the amount of breastfeeding that is taking place. So here, if we're talking about different types of scenarios and what the variables are. So let's say number one, a children's reading skill is measured after taking either a special reading class or a standard reading class. If you were to say, and what would be the independent variable? And in that case, it would be the type of reading class. And then for your dependent variable, it would be the child's reading skill. Number two, college students' memory for German vocabulary words is tested after a normal night's sleep or a night of no sleep. So, what you're looking for there in the independent variable is the quality of sleep, right? So the amount of sleep they're getting, and then their dependent variable will be their, ability on a test. The experiment title, the effect of a daily walking program on an elderly person's lung capacity. Independent variable is the amount of walking, whereas the lung capacity will be your dependent variable. Okay? And then number four, people's ability to avoid accidents in a driving simulator is tested before, during, and after talking on a cell phone. So your independent variable would be cell phone usage, whereas the dependent variable will be performance on the test. Now, there are some flaws in experiments because there are things that can happen. So you have the placebo effect, which is a treatment that contains nothing known to be helpful, meaning it's just it's a fake pill, so to speak, but that nevertheless produces benefits because a person believes it will be beneficial. So it's kind of it's one of those weird things that happens that when you start believing something's going to work, it starts to work. So it's mind effect over the body. So how how do like experimenters like negate this effect? They can use an extra control group, a placebo group. They may receive a placebo, a treatment that appears to be, the same. So like you have different groups to kind of like see what the effects will be and if there is any real difference.
What if you found out the medicine your doctor's been giving you wasn't proven to make you feel any better, but yet you did get better? This is called the placebo effect. It's one of the strangest and least understood phenomenons. It's most often used in pharmaceutical clinical trials to prove the efficiency of new drugs. But what's interesting is that it also occurs in animals. Studies observing Siberian hamsters revealed that when hamsters were made to believe it was wintertime, their immune systems went to a more dormant state to preserve energy. For some reason, the placebo effect doesn't work unless there's a source of external influence to initiate a sequence of events. What's strange is the external influence may differ. The placebo effect is bigger when the pill itself is bigger, or when you take a capsule instead of a pill. And there's even a placebo surgery, which outperforms both combined. But that's not all. Placebos can also be addictive. In one study, a group of women took placebos for more than 5 years. Surprisingly, 40% of them experienced withdrawals afterward. Placebos are geographically sensitive, meaning that their effects differ depending on where you live. For example, using placebo to treat ulcers worked better in Germany than anywhere else in Europe. And when Valium was tested in France, it outperformed the placebo. But when tested in the United States, it failed the test. And as our medical technology improves, our faith in medical professionals improves. With this said, the placebo effect has been shown to simultaneously grow.
Very strange effect, isn't it? But it's also can be, it's worth studying. Okay. So another thing that, can be a flaw in an experiment is, random assignment. So you're assigning participants to experimental and control conditions by random assignment minimizes the pre-existing differences between the two groups. So in order to kind of like deal with this, you just randomly assign and then see what happens. So, for example, when the breastfeeding example that we just gave, like you would definitely want to randomly assign your people because you're controlling for other variables. That's the idea. So truly random samples allow every member of a population an equal chance of being selected. So researchers try to draw their participants as randomly as possible from the population available. So they don't want to have all women of a certain race in this particular example, or all women of a certain background. Like, they want different cultures. They want as many different people as they can get to see if this is actually a thing. Okay. And then there's a representative sample. So to generalize to the larger population from the representative sample, you're trying to build up, like you want to get like something that reflects what actually people look like as well. Okay. So sometime research participants out of like sometimes they'll like have people who are super enthusiastic or personal beliefs, they can affect the outcome of an experiment. So like you want, like sometimes the experimenter wants so bad for a certain outcome that they will actually like alter the outcomes. And there's a famous case, the John study, which I'll tell you about in a little bit, or I've taught you about before, which is the student who, the child who was mutilated at birth on a surgery gone wrong, and he had to have his genitals removed. And so they essentially gave him female sexual organs. And what ended up happening is that the scientist in charge of this started treating him like a girl because he had girl parts, even though he was a boy at birth. And it ended up causing a lot of problems. And so the experimenter wanted to, he was so desperate to prove that this was going to work, and it proved his theories, that it ended up not really working to what he was thinking. So in order to control experimenter bias, there are different types of procedures. So you have a single blind experiment, which is that participants don't know whether they're receiving the treatment or not. Okay? So the experimenter knows, but the participants don't. Now, this can still lead into some experimenter bias. So this is why, to control for this, you have what's known as a double-blind experiment, which the participants and the researchers are unaware of who has obtained the treatment. So you don't actually know who's getting, say, the placebo or the real medicine. And the idea is that you're trying to you're trying to see, which ones work and which ones don't. So, like, the participants are just taking a medicine that they think will work. And the researchers, in order to prevent accidental bias, are trying to make sure that they're treating it as everybody's getting the same thing. Okay, so that's the end of this section. Hopefully, you came away learning a little something about research methods again. So we'll talk more about this later, and I will, especially as we get ready to come together, and I can't wait to see you all soon. Okay, have a good day. Bye.